Alright, so this is lab 3, finding the mass of a black hole. We have two major principles for this lab. The momentum principle, which is the F net vector equals delta P vector over delta T, or change in momentum over change in time. And Newton's universal law of gravitation, which is, in this case we're looking at the magnitude. The magnitude of gravitic force is equal to the G constant times the star mass times the black hole mass over the vector of the star minus the vector of the black hole, and that magnitude squared. And here's the G constant for this equation. And in this system, it's only the star, and the forces acting on the star is only gravity from the black hole. And because gravity is the only force acting on the star, the net force is equal to the gravitic force, or this formula. And so to find the mass of the black hole, we can rearrange this formula, where this is the new formula, where we put mass of black hole alone on one side and put everything else on the other side through algebra. And the mass was determined to be 1.99 times 10 to the 31 kilograms. We're looking also at the fact that the parallel net force and perpendicular net force equals the total net force. And it should be noted that net force is not equal precisely to dP over dt. Rather, they're equal in value, but net force causes a change in momentum over time. And this is the same for the net force parallel and net force perpendicular on their dP over dt's as well. So here's my VPython file. The mass of the star is here. The period of change in time is here, which is 86,400 seconds, or 1 day. The start time is 0. Here's the gravitational constant. And if we go down, the x and y positions and the x velocities and y velocities are all determined from the stardata.csv spreadsheet. And these velocities are expressed as vectors here. And the initial momentum is equal to mass of star times initial velocity, and final momentum is equal to mass of star times final velocity. And the change in velocity is v final minus v initial, and the change in momentum is p final minus p initial. So dp dt is equal to delta p over delta t. F net is equal to dp dt, but they are not the same thing, although they equal each other. F net causes a change in momentum, as we said earlier. P hat is just a directional vector, and d mag pdt is the magnitude of the final momentum minus the magnitude of the initial momentum divided by a change in time, and dp dt parallel is equal to d mag pdt times p hat. And F net parallel is equal to dp dt parallel, and dp dt perpendicular is equal to dp dt minus dp dt parallel, and the F net perpendicular is equal to dp dt perpendicular. And the black hole mass formula, the way we rearrange the Newton's universal law of gravitation, is here to determine the mass. And if we run this module, we end up with this, where the black arrow is the parallel force, the yellow is the complete net force, and the blue arrow represents the perpendicular force. And this mass was determined to be 1.99 times 10 to the 31st kilograms. And we were asked if we replace this black hole with a different black hole, and this motion stayed the same for the star, and the mass of the star remained the same, would we find a different mass for this new black hole? And the answer is no, because if there was no change in the motion of the star, that means there was no change in velocity, change in position, momentum, or the force caused on this to make it go in this curved direction and at the speed that it's going, because parallel force affects speed and perpendicular force affects the curve amount of curve of the object. And so because all of the position from the origin is the same, the masses are the same, and everything else is the same, we end up with a black hole with the same mass. Thank you. I hope you enjoyed the lab.